Hi guys and girls on YouTube, welcome to my channel. Just a really quick video here, and the reason this is quick, I didn't think I'd be able to repair this, so I didn't video the repair. But you don't need to see that anyway. All you need to see is what was wrong with it and how I fixed it. Now we're talking here a radio spares 5,000 watt power inverter. This is 24 volts in and mains out. Now these are a lot of money. So if we look at the RS website, that's the one there, and it's £801.76. Now I don't usually take stuff like this on, but I did agree to have a quick look at it with it being a radio spares unit. I thought there might have been more chance of repairing it with it being RS supplied. Now it actually came in completely dead, no lights, no bleeping, no nothing at all on the front, and the guy says he connected it the wrong way around. Well, if you look at the negative terminal there, you can see how it's all melted, where he's actually touched onto it. So I really didn't think this was going to be repairable, but guess what? I found the fault on it, I fixed it, and it's up and running. So let's have a look what the problem was. Right, so that's the inside view, and this is what I saw when I took the lid off. There's a pair of resistors there, completely burnt up. They're that burnt you don't even know what value they are. Also, there's a little board standing up there with a device on a TO220 device, and there's a resistor on there. You can just about see it now, that also looks like it's got hot, and a couple of wires going to a capacitor, which is like strapped to the back. This looks like they forgot to put something in and they've added it on later. You can also see that that's got hot, so that device has got very hot. Now it says down there 24 or 48, I've no idea what that means. But them two fuses next to it, they were okay, and there's two devices there. I've actually connected this to power. Them two resistors getting hot, and these two devices and that resistor on there were all burning up. So what I've done is I've drawn the circuit diagram the best I can, and as soon as I'd drawn it out, I'd identified what the problem was. So let's just take a quick look at the diagram I've made. So that's one I've drawn down roughly. I've translated that into something a bit better to see here. And now this circuit, all it seems to do is it takes 24 volt in and it gives 12 volt out. Now I think the reason for all this lot, it's to lower the overhead on that regulator, so we're not dropping 24 down to 12. So there's a lesser input to output difference. But these bits here, these are mounted on that little subboard that's standing up, and they're the two resistors that burnt up. Now, even though the resistors are completely burnt, they are still actually working, and I'm measuring to 36 ohms for the parallel pair. So although we don't have the value on these, I would imagine they're probably 68 ohms each, these resistors. But you can see it's quite a basic diagram. There's a Zener diode there. Now I found if you disconnect that resistor there and power it up, you got 15 volts here. So that's lowered the input output difference of the regulator by just down to 3 volts. Now they were burning up, that was getting hot, that was getting hot. I've disconnected there. I only had 3 volts there, so I've disconnected this resistor. It's come back up to 15 volts there, so that indicates that either part faulty is on here, because that was also burning up, or it's something further back. Now what I actually found is it was this L7812CV regulator that's shorted, and that is mounted. I'll just show you, that's soldered to that little sub panel, and that's it there with the capacitor strapped on top. That's the resistor was getting hot, so I've just changed that. Although that resistor's got hot and they've got hot, they're all both working. It's enough for me to test it before I put new ones in, but that was the problem there, that 12-volt regulator. And here we go. I've got it connected to my bench power supply. Let's flick it on. I've got this 60-watt bulb connected to it. And there it is, working, lighting a 60-watt bulb. Of input current is 4.32 amp. So there you go, that's all you need to know really. What was wrong with it, how I fixed it. It wasn't as difficult as I thought it might have been. When I first saw them resistors, I thought this might have been a no hope, but it is actually working fine with them two resistors. They're obviously some sort of wire wound type. They're designed to take a lot of hammer, but I am going to put a couple of new ones in just in case, and I'm going to be putting 268 ohms in, which will make approximately 36. Alright guys and girls on YouTube, many thanks for watching my channel, and I'll catch you in the next video then. Goodbye.